February 1945. A Marine private crouches in a shell crater on Iwo Jima, 70 meters from a fortified Japanese cave position. Strapped to his back are two cylindrical tanks containing 70 pounds of thickened gasoline under pressure. A hose runs from the tanks to a metal wand gripped in both hands. He has been carrying this equipment for 6 hours. His hands shake, not from fear of the enemy, though that fear is real, but from what he carries. Another Marine nearby took a rifle round through his fuel tank 3 days earlier. The resulting fireball killed him and 2 men standing within 10 feet. The private knows this. Everyone in the flamethrower section knows this. He rises from the crater and advances toward the cave entrance. Japanese machine gun fire opens up immediately. Rounds snap past his head. One strikes the cave wall near him. None hit the tanks. Not yet. He reaches effective range, approximately 30 meters, and pulls the igniter trigger. A jet of flaming liquid shoots forward, splashing against the cave entrance and rolling inside. Screaming begins immediately. The private holds the trigger for 4 seconds, emptying a quarter of his fuel supply, then drops back into cover. His hands are still shaking. They will shake for the rest of his life when he thinks about what he carried on Iwo Jima. The M2 flamethrower won battles, but the men who carried it into combat feared their own weapon almost as much as the enemy did. The United States military entered the Pacific War with a flamethrower problem that was tactical and psychological. Japanese defensive doctrine emphasized fortified positions, bunkers, caves, and interconnected tunnel systems that were nearly invulnerable to conventional weapons. Artillery could seal cave entrances temporarily, but it rarely destroyed the positions entirely. Small arms fire was useless against concrete and earth. Grenades had a limited effect in deep fortifications. Explosive charges required a close approach under fire, and even successful demolition often left secondary positions intact. What infantry commanders needed was a weapon that could project lethal force into spaces that bullets and shrapnel could not reach, that could kill defenders without requiring physical entry into their positions, and that could neutralize fortifications quickly enough to maintain offensive momentum. Flamethrowers existed, but early models were inadequate. The M1 flamethrower, introduced in 1942, was mechanically unreliable and had insufficient range. Effective firing distance was approximately 20 meters, requiring operators to expose themselves to devastating close-range fire. Fuel capacity was limited, providing only 8 to 10 seconds of continuous flame. The ignition system frequently failed in humid conditions. Most critically, the weapon's bulk and weight made operators obvious targets. Japanese defenders learned quickly to prioritize flamethrower operators, knowing that eliminating them could halt an entire assault. The M2 flamethrower, standardized in 1943, addressed some of these limitations while introducing new ones. Development was conducted by the Chemical Warfare Service at Edgewood Arsenal, Maryland. The design team, led by military engineers whose names remain largely unrecorded, approached the problem systematically. The weapon needed a greater range, increased fuel capacity, improved reliability, and some measure of protection for the operator. These requirements were contradictory. A greater range required higher pressure, which meant heavier tanks and greater explosion risk if punctured. Increased fuel capacity added weight, making operators slower and more vulnerable. Improved reliability required more complex mechanisms, creating additional failure points. The final design represented compromises across all parameters. The M2 consisted of 2 cylindrical fuel tanks worn as a backpack, a pressure tank, a fuel hose, and a firing wand. The total weight when fully loaded was approximately 70 pounds. The fuel tanks held roughly 4 gallons of thickened gasoline, created by mixing standard gasoline with a powdered aluminum soap compound that increased viscosity. This thickened fuel, often called napalm, though technically a different formulation, had critical advantages over straight gasoline. It adhered to surfaces rather than running off. It burned longer, approximately 15 to 30 seconds per ignited patch. It could not be easily extinguished with water. Most importantly, it projected further as a coherent stream rather than dispersing into droplets. The pressure system used nitrogen stored in a small cylinder at approximately 200 pounds per square inch. This pressure drove fuel through the hose when the operator opened the fuel valve. Maximum range under optimal conditions was approximately 40 meters, though effective combat range was closer to 30 meters. Wind, elevation, and fuel viscosity all affected actual distance. The ignition system consisted of a spark generator mounted on the wand. When the operator pulled the rear trigger, it opened the fuel valve. Pulling the forward trigger activated the spark generator, igniting the fuel stream as it exited the nozzle. In theory, this two-trigger system provided control and safety. In practice, it required precise coordination under combat stress. The flame itself was devastating. The burning thickened fuel reached temperatures exceeding 1,000 degrees Celsius. Direct contact caused instant third-degree burns. Indirect exposure within enclosed spaces caused death by oxygen depletion, carbon monoxide poisoning, or thermal trauma to the lungs. The psychological effect on both targets and operators was profound. Japanese defenders faced a weapon that could reach them regardless of cover, that burned slowly enough to ensure agonizing death if they were caught, and that could not be countered with small arms fire against the flame itself. American operators faced the knowledge that they carried highly flammable material in thin metal tanks directly against their backs while advancing into enemy fire. Training for flamethrower operators began at bases in the United States and continued at forward staging areas in the Pacific. The curriculum emphasized mechanical operation, range estimation, fuel conservation, and immediate action drills for equipment failures. What training could not adequately prepare operators for was the psychological dimension. Instructors could demonstrate the weapon's effectiveness. They could not simulate the experience of feeling rifle rounds impacting near the fuel tanks or hearing the specific sound that pressurized gasoline made when a tank was punctured. Combat veterans from Guadalcanal and Tarawa provided informal instruction that official training manuals omitted. They taught new operators to advance in short rushes, to avoid silhouetting themselves against flame, and to never carry more fuel than mission requirements demanded. They explained that flame operators had life expectancies measured in minutes once combat began, and that Japanese marksmen would target them preferentially. Some of this instruction was exaggerated, based on isolated incidents rather than statistical analysis, but the fear it generated was real and affected operator performance. Operational deployment began in late 1943 across the Pacific Theater. The M2 saw extensive use on Tarawa, where Marine flamethrower teams eliminated fortified positions that had withstood hours of naval bombardment. On Saipan in mid-1944, Army and Marine flamethrower sections became standard components of assault teams tasked with cave clearing. The typical tactical employment involved a rifle squad providing suppressive fire while the flamethrower operator advanced to effective range, discharged flame into the target, then withdrew under covering fire. This required coordination and discipline that often broke down under combat conditions. Operators frequently found themselves advancing alone or with minimal support. Range estimation was difficult. Operators would sometimes discharge flame at excessive distances, wasting fuel without effect, or wait too long and expose themselves to point-blank fire. The weapon's distinctive silhouette made operators identifiable even before they fired. Japanese defenders developed specific countermeasures. Snipers were instructed to target flamethrower operators first. Machine gun positions were sighted to cover likely approach routes. Some Japanese soldiers waited until operators were within range, then attempted to ignite fuel tanks with tracer rounds or grenades. This tactic was rarely successful, but the threat affected operator psychology substantially. On Peleliu, in September 1944, flamethrower operations reached their tactical apex and revealed the weapon's deepest psychological costs. The island's coral cave systems were nearly impervious to conventional weapons. Flamethrowers became the primary method of neutralizing these positions. Marine Corps flamethrower sections operated continuously for weeks, moving from cave to cave, often advancing multiple times per day. Casualty rates among flame operators were documented as approximately 30%, significantly higher than those of infantry riflemen. Analysis suggested these casualties resulted not from flamethrower-specific targeting, but from the requirement to advance closer to enemy positions than other personnel. The distinction was irrelevant to operators. They knew they were more likely to die than their squad mates. This knowledge affected performance. Some operators became reckless, advancing too quickly in an attempt to complete their mission and withdraw before being targeted. Others became hesitant, firing from excessive range or refusing to advance at all. Unit cohesion was affected. Riflemen sometimes refused to provide adequate covering fire, unwilling to expose themselves to protect an operator they considered already doomed. Flamethrower sections developed a reputation as expendable assets, a designation that was never official but became understood implicitly. The weapon's effect on its targets compounded the psychological burden on operators. Unlike rifles or grenades which killed quickly, the flamethrower produced prolonged, visible suffering. Operators heard screaming, they smelled burning flesh. They sometimes saw burning figures emerge from fortifications attempting to escape. Rules of engagement in the Pacific were brutal by any standard, but even in that context, the flamethrower represented a category of violence that disturbed many who employed it. After-action reports from Iwo Jima and Okinawa include references to operators requesting transfer from flamethrower duties. Some requests were granted, most were denied due to personnel shortages and operational requirements. Psychiatric casualties among flamethrower operators were noted but not systematically studied during the war. Post-war analysis suggested rates of combat stress reaction were elevated compared to other infantry specialties, though definitive data were never compiled. Comparison with flamethrowers used by other nations provides context. German forces employed the Flammenwerfer 41, a smaller, lighter weapon with approximately 10 liters of capacity and 25-meter range. It was designed for assault infantry rather than fortification reduction and emphasized mobility over sustained fire. Soviet forces used the ROKS-3 flamethrower, a backpack system similar to the M2 but with lower pressure and shorter range. British and Canadian forces used the WASP, a flamethrower mounted on universal carrier vehicles which provided armor protection for operators but limited mobility in rough terrain. Japanese forces developed their own flamethrowers but used them sparingly, primarily in defensive roles. None of these weapons approached the M2's combination of range, fuel capacity, and effectiveness against fortified positions. None imposed the same psychological costs on operators. The M2 was the most effective infantry flamethrower of the war. It was also the one operators feared most. Technical limitations were multiple and significant. The fuel mixture degraded in tropical heat, becoming either too viscous to flow properly or too thin to project effectively. Humidity corroded electrical components in the ignition system, causing frequent misfires. The pressure regulator occasionally failed, either releasing too little pressure for the effective range or too much, rupturing fuel lines. Fuel leaks were common, creating fire hazards without obvious external damage. The wand assembly was fragile and bent easily when operators fell or crawled. Replacement parts were chronically short in forward areas. Maintenance required specialized training that frontline infantry often lacked. Most critically, the tanks themselves, while constructed from steel, were not bulletproof. A direct hit from a rifle round would not necessarily penetrate, but repeated impacts or hits from larger caliber weapons could breach the tanks. When this occurred, the results varied. Sometimes fuel leaked slowly, requiring the operator to remove the weapon and withdraw. Sometimes the leak was rapid, emptying the tanks in seconds. Sometimes the escaping fuel ignited immediately, either from nearby flame or from sparks generated by the penetrating round. Operators who survived tank penetrations uniformly described the experience as the most terrifying of their combat service. The knowledge that this could occur at any moment, with no warning and no defense, was psychologically corrosive. By 1945, flamethrower doctrine had evolved to minimize operator exposure. Tank-mounted flamethrowers were developed, mounting M2 components on Sherman tanks with armored fuel tanks and remote firing mechanisms. These proved effective on Iwo Jima and Okinawa, reducing infantry flamethrower requirements. Napalm bombs dropped from aircraft began to replace some tactical flamethrower missions, delivering area effects without requiring close approach. Portable flamethrowers remained necessary for cave and bunker clearing, but were employed more selectively. Operators were rotated more frequently, though definitions of frequent rotation remained relative. Some men carried flamethrowers for a single mission, others carried them for weeks. Statistical analysis of casualty data after the war suggested operator survival was primarily a function of mission duration and frequency rather than individual skill or training, a conclusion that validated operators' fatalistic attitudes. The M2 remained in U.S. inventory through the Korean War and into Vietnam, with minor modifications. Its tactical effectiveness was never questioned. Its psychological costs were never adequately addressed. Post-traumatic stress among World War II flamethrower operators was documented in veteran surveys conducted decades after the war, showing elevated rates compared to other infantry specialties. The specific trauma appeared to derive not from fear of death, which was common to all combat personnel, but from the prolonged anticipation of a particular form of death, burning alive due to one's own equipment, and from the moral injury associated with the weapon's effects on its targets. These findings came too late to influence wartime training or deployment policies. Approximately 24,000 M2 flamethrowers were produced during World War II. Casualty rates among operators were never officially compiled with sufficient precision to establish definitive statistics. Estimates based on unit records suggest several thousand operators were killed or wounded while carrying flamethrowers. The number of people who survived physically but carried psychological scars specifically associated with the weapon is unknown. What is documented is that the flamethrower sections on Iwo Jima, Okinawa, and other Pacific battlefields were staffed by men who understood they carried death on their backs and advanced anyway, not because they were unafraid, but because the mission required it. Some of them are still afraid.